Hi everyone, today I will introduce our paper FashionR2R. Modeling and producing human images has attracted researchers from different areas for decades. Rendering algorithms decompose and simulate the imaging process of a camera, while are limited by the trade-off between modeling accuracy and computation efficiency. Generative models can produce human images with impressive authenticity, but still lacking controllability and editability. In this paper, we study rendered-to-real image translation. We want to maintain the digital human identity and clothing design, while enhancing the fine-grained details such as skin texture and clothing wrinkles. Previous works can be roughly divided into two groups. One is to directly solve this rendered-to-real image translation problem by modeling variables from rendering and mainly deal with indoor or outdoor scene enhancement. The other is to apply general image-to-image translation methods or style transfer, but still have difficulty in enhancing specific photorealism while preserving fine-grained details. In this paper, we propose a novel framework for rendered-to-real fashion image translation. Our main idea consists of two aspects. Firstly, we want to leverage abundant generative prior from pre-trained text to image diffusion model. Secondly, we want to exploit the decoupled features in the U-net structure to preserve fine-grained details during image translation. Our framework has two stages. In domain knowledge injection, we adopt positive domain fine-tuning on real images and negative domain embedding from rendered images to inject knowledge into a pre-trained diffusion model. In realistic image generation, we apply rendered-to-real image translation with a texture-preserving attention control to preserve fine-grained clothing textures. We discover that the attention maps in the shallow layers of the U-net contains rich spatial structure and can be used for fine-grained texture preserving. So we inject query and key of the self-attention from the rendered image inversion to the rendered-to-real image generation pipeline. We evaluate our method on face synthetics and our collected SynFashion dataset. For quantitative results, we adopt KIDLP, IPSA, SSIM. Since quantifying photorealism is still an open problem, we also adopt user studies to compare among all methods. For SynFashion dataset, we collect 10,000 rendered images using Style 3D Studio. Our method significantly improved the realism of rendered human faces while maintaining the original human identity and clothing details. On SynFashion, our method removed the unnatural lighting effect and added clothing wrinkles to improve the realism. We achieved the best KID for realism enhancement, while having comparable LPIPSA and SSIM for consistency maintenance. The user studies also show significant preference for our method. We conducted ablation studies in a drop-one-out manner. Without source embedding, the model tends to recover the input rendered image. Without target fine-tuning, the output is not real enough. Without TAC, face identity and clothing design can change significantly. We also conduct further analysis on denoising strength and ratio of T, as C steps. With a high denoising strength, the generated images resemble realistic images more closely but retain fewer details from the original rendered image. Increasing the T-AC ratio helps to better preserve the texture details and facial features. In conclusion, we propose a novel framework for rendered-to-real fashion image translation. Our framework consists of two stages: domain knowledge injection and realistic image generation. Moreover, we collect SynFashion dataset to promote research in this important area.